for this particular server, for this particular domain, and then it can forward your request. So that's a domain name lookup. Okay. Now, the server may say, okay, I know about that, but I have to redirect you to another server. Okay. Then that's what it will do, and your browser will follow it. Sometimes you might even have that redirect cached in your browser. There's a whole bunch of ways that these things can be managed, mismanaged, but at the end of the day, it's going to find a way to point you to where you expect it to be, and that will be a number. At the end of the day, everything is a number. So it's like the phone system. You call up an operator, I need to get in touch with the cab company, and so on and so forth, until they give you the phone number, you call up, yeah, we'll send you a cab. This was, logic was before Lyft and Uber. So now we're going to go to what you need to run Drupal 8 on a server. So generally, you're using Linux. There's ways to run it on Windows. I don't advise it, but it is possible. There's ways to run it on right on your Mac, native, right as a file on your desktop if you wanted to. Also, not the best situation, but it will run generally. You've got Ubuntu and Red Hat and all the different Linux flavors. Most of them will support Drupal. You then have your HTTP, Apache HTTP, Hypertext Transport Protocol, I believe is what it stands for. What it does is Apache gets your request. It first goes to Apache, and Apache says, I'm sitting here waiting on this server, and you sent me something, and I got it now, and I'm going to find a way to get you return your request. There's also Nginx, which is very similar to Apache. There are some distinctions between Apache and Nginx, where you can use them for other load balancing. Nginx is good for load balancing. There's different ways that you can use each of these, but generally one or two of them is doing the job on a site hosted on Linux. And then you have PHP. Now PHP is an application. It's almost you could call it a library. It manages scripts. Your scripts look up primitive parts of PHP that make up some of these scripts, and it's stored on the server. So if it says a certain PHP function is set, is this set? PHP knows how to handle that is set and checks to see if something exists or not. So it's a whole structure of code that lets you, instead of writing binary, 60, 80 lines to figure out if something is set or not, PHP gives you those primitives, and it lets you assemble them into, it assembles it into a language for you. And Drupal is written in PHP. So Drupal uses the PHP language, just like you go to get your road test, and the driver's manual is written in English or Spanish or whatever other language they support down at the motor vehicle. But it's the content, you separate the content from the language that it's written in, and that's what PHP does. It gives you a language and a structure to write commands that the server can follow. Mostly, or a lot of it, is accessing the database. Now, Drupal uses MySQL.
So I have a question.
Shoot.
Hey, so let me see if I get this straight. So kind of like, when I think about a page request, I think about like in what order things are executed.
Yes.
So let's say we're just talking at the Drupal level now. So when a page is requested, does Drupal then talk to PHP, which then talks to the server? Is that how it works, like that?
Okay. Apache talks to PHP, which is the language that Drupal uses. So it will talk to Drupal using the PHP language.
I see.
And then PHP will instruct Drupal what it needs, and Drupal will look for content in the database. It will look for configuration in the database. So the database is where Drupal finds everything it needs, and that starts out with Apache saying you need to find where this content is. I'm going to give you that request in PHP so you understand what I'm talking about. And then Drupal says, great, I understand you. I now need to go into the database and find exactly what you're looking for. And it could be configuration or content.
Thank you.
Sure thing. So we go from here, and the web server software, once again Apache, receives a request and passes it to a specific file. So the request is just it's the URL, and there's a header. It gives you a bunch of information about some circumstances surrounding this request. But at that point, it knows where index.php is on the server, and it says, index.php, here, you handle this now. You take this and start generating content off of this this URL that we've structured, and it represents real content that you can return to a user. So where index.php is the document root directory, and what that means is that's where you'll find your Drupal core directory and the theme directory now in 8 and modules and all the different include files. That's the main folder of Drupal, and index.php is the door. Is where the request gets passed to initially. So, and we call that the document root directory. And in Apache, there's something called directory index, and it says, where's the index folder? And it knows it's in its configuration and doesn't have to think about it or go searching for anything. It has the address and heads right over there. So now, as I said, the index.php is found in the Drupal root directory, and that is generally with every single installation of Drupal, you'll start out with this. If you need to change it, that sometimes happens. I don't recommend it, but it could. And but the bottom line is that when you untar a Drupal archive, and you pull it down and it's your new version 8.43 or whatever the next one is, it's there, and it's structured that way. So and sometimes people give that the root directory a nickname like web or HTML or docroot, but generally it's on Linux they put it at var/ww/ and whatever name they're giving it in your particular case. But the Apache instance will know that that's your document root. And that's where it has to go. So this should look familiar to many people of, yeah, I just, decompressed a Drupal tar file or a zip file, and this is what I got. I got a bunch of files in here that I'm not 100% sure what they do, and I have core. This files one over here. Whoop, hello. Yeah, this files one, that could be the files from your sites directory, but no big deal. It's the index.php we're worried about right now. So we take that, and this is what index.php generally looks like. This is straight out of core. You don't want to hack this. This is your Bible. So what it says in short is, it says use Drupal /core Drupal kernel. It's going to look for a class called Drupal kernel. And it says Drupal kernel is like the beginning point. I've given you the URL. Now you have to give it to Drupal, and that's where Drupal starts to build the functionality and assemble all the code that it needs to run all of your commands. And what it also does is it builds something from Symfony, which is Symfony is the routing system of Drupal. So Symfony we used to have in Drupal 7, we used to have a menu system, and it essentially did the same thing, but not as well. And they decided we're going to put Drupal on top of Symfony, and Symfony was really good at handling requests, still is. So it would take your request and it would package it up and then build the Drupal kernel. So that says, what do we need from Drupal? What do we need from Symfony? We're going to give it a request. Let's get all that code together. Autoloader. What Autoloader does is it pulls in a lot of PHP packages from Composer. So they're not in Drupal core. They're not part of the Drupal module system. They're additional PHP scripts. We pull that in. So then we give the value of $kernel. It's a variable, and we use that class, that PHP code, to build all the to build a variable that has all the pieces in it that we're going to use to generate this page. So now we have the request. It says is equal to request create from globals. This is another class. It takes all of the pieces from your from the header of your request and starts to put that together. What's your timeout? What are some of the details of this request that we need to know? Now here's the beauty. Response, that means what am I going to send back, is equal to the kernel, which is an object. It has all the pieces in it that come from Drupal code, and inside that object is a method called handle, meaning do what you got to do with it, and then request, which is here's what this person sent us. So it's like you want to send them back something, put this abstract variable together. It's an object, and take their request and run it through whatever it needs to have to give him back or her back what they asked for. Then you have something. The response has also a method in it called send. So it prepares it to go. Okay, it starts. Send is another function that it just goes through and says, okay, let's clean this up. Let's make it presentable. It's going to go to HTML. Do we have all the pieces that we need? That would be the send function. And then at the end of it, once you've created this send, and it may pass it, I think send passes it back to Apache. Then the kernel has another method, another function in it called terminate. It's all over now, folks. We did our job. Let's clear the RAM so we don't have this hanging around for the next 3,000 page requests. We're going to clear it out and get ready to start a new one. So this index.php encapsulates the whole Drupal process. Okay, so now it's Symfony that creates the request, because that's the routing system. That's what actually talks to Apache. And it provides the HTTP functionality Drupal will need to deliver a response, which is not the page building necessarily. Sometimes it's headers. Sometimes it's just getting everything ready for Apache to go, okay, you take it now and send it back to those people that asked for it. So, and you could look up in sitepoint.com, there's Symfony Drupal 8, and it'll tell you a lot more detail about how this works. But that's the Symfony gets it on the front end, passes it to Drupal, and then it comes back from Drupal to Symfony to Apache. So it just does a complete U-turn, but it goes through some changes in the process. All right, so one of the things that happens is this auto load. Auto load directs Composer to get the PHP packages. These can be sitting in a directory in the site root. They're generally customized for your site. You probably have a lot of them that everyone else has, and then you might have a few that are strictly unique to you. But autoload gets those pieces together and goes, okay, Drupal, we got some more code for you. Here, If it's applicable, run these. And this is sort of a slowed down version of what that first part was. We create the Drupal kernel. Now, Drupal kernel is a function of Drupal. So all it says is Drupal, you know what to do. Kernel is the core element, so it can build a page. It's not necessarily the contributed modules, although it doesn't exclude them. But the Drupal kernel is the core functionality of Drupal in code. And it also, at that point, finds in your sites folder which sites folder you're going to use, and then goes in and says, hey, you're telling me there's a database out there somewhere. I'm going to go start to access this database so I can get configuration, so I can get content, and it starts to put together all the processes that Drupal will use, and it takes all of that and puts it into RAM. Now, RAM is a really critical part of this, because if you don't have enough RAM, I don't know any developer who's never gotten an out-of-memory error on any site that they've built, and if you load up too much content, load up too much code, it will not fit into the RAM you have available to allocate. That happens. So this is what Drupal kernel is doing, is it's assembling all this code and going, all right, you're in RAM. RAM is great because I can access you instantly. And when I need a specific line of code, it's in RAM. It's very fast. I just pull it out and use it. Okay, Drupal goes into the database and loads the configuration. What? I don't know what page it is. It may not need everything at once. It may need some things. It may need to go into the variable table. I don't know if 8 has a variable table, but different settings of which theme are we using, what's the site name, what page are we on, all these pieces start to come out of the database. One of the first things it looks for is a URL alias. You might have put in a URL that has been aliased, so it's actually node 62, but Drupal says, okay, it's called My Happy Vacation, and you go into the alias table and say, what's My Happy Vacation? Oh, that's node 62. So Drupal will know that it has to start loading node 62 based on what the alias is set to. Aliases are for humans. Node IDs are for machines. Stan.
Yeah, I have a question. So is there some place where you could look at like a hierarchy of where these things are called?
Yeah, in the configuration page, there's a menu that you can select called URL alias, and it has a whole list on some sites, thousands of entries to see which strings of text represent node /62 or whatever number is there. So and that's all stored in the database. And that's why Drupal needs to make that database connection first, because it needs to parse out this these aliases and convert them into a number.
So does it automatically check the alias table first?
It's early in the process. I haven't run a page load and given everything in it, because we can go through 500 different functions that it might go through, and that gets really worse than this. Yeah, but it does. It loads that early, and if you're looking for content, that'll help you direct you to the actual piece of content that's stored in the database. Okay, yeah, the URL is compared for aliases. And here I have a relative URL that probably wouldn't have an alias because it's an admin, it's a back-end path. And generally, we leave those alone because the developers will know that admin /something is their territory, so we don't change that. But the content, when your user goes to the site and they look up in the address bar, they want to see words and not Drupal numbers and configuration. So that's what the two pieces of an alias are: the original, which is the Drupal language, and a string that a user can sort of understand. A lot of dashes in it, and you know, it's not a perfect situation, but it's a lot better than a blind number. Okay, so from this, Drupal parses the internal system path. This is where the magic really starts to happen, because now this path, which is converted to a number, can be passed to the database and content can be loaded, which is the first part of satisfying that request. So if you go into, you find out your real path is /node/62. What it does, it says, okay, let's assemble node 62 and let's go into that database and pull out every single field in there that references the number 62 for a node ID, and it has content in there, and that's how it makes that connection of, here's node 62, there's a body, there's a title, there's a, what do you call it, taxonomy term that might be related to it, there's a, some images that might be attached to node 62, and that's how it goes through the database and finds you all the pieces, so that when that page loads up, you look at Devel, hopefully, and Devel says, okay, here's your node ID, your version ID, your created by, and all the bits and pieces that make up that, that node. This is where Drupal makes all those pieces come together. Because unlike, everybody has a vision of Drupal as like this big spreadsheet, and it's like node 62, and you go, here's a column, here's a column, here's a column. And it's the exact opposite of that. Every big data guy I've talked to, they go, okay, where's that view? And I'm like, no, that doesn't exist. Drupal, what it is, in order to keep the information compact, it only puts populated fields in there. So your database is a little smaller, and it doesn't have to go through every single possibility. It'll go from node 1 to 16 to 22 to whatever number actually has data, and pull out the data from the database, and not this whole huge grid that might have empty chunks in it, and now you have to keep a place for that, because that's more, what do you call it, space intensive. And so that's one of the things about Drupal that's unique. And if people tell you, oh, I hate Drupal, which there are big data guys who do that, that's the reason. It doesn't follow their logic. It follows logic that was written by the early developers of Drupal, so that it can work efficiently, and it can go through databases and find exactly what it needs and not have to spool through endless lists of empty stuff. So okay, using the path provided in the request, Drupal uses routing to match the path arguments to functionality. Meaning, if the alias takes you to /node, it knows you're building a node. If it takes you to /admin, something or other, it might be, let's load that form. If it's /file, it's going to say, I want to edit my my file, that you know, my media item. And I want to go there, and I want to know exactly which image proxy to load. That's where it starts to go down that road. So so from there, it builds the node, and it knows, one of the first thing it does is it says, what's the content type for here? Is it a user profile? Is it a node of type whatever? One node, an article or page or whatever it is, might have 50 fields, and another one might have 6 fields. So it's also to speed things up. It says, okay, I'm in a node that has 6 fields. I only have to go look for the 6 fields with the number 62 to build this node. So it's a way of keeping your site performant, which is what makes this magical, because what you're doing is, you've got thousands of lines of code. You have thousands of lines in databases. I mean, I've worked with databases that are a couple of hundred gigs, couple of 100 gigs of data. How does it find all that stuff so fast? This is what it does. It says, okay, I'm going to make it a little easier, and I'm not going to make you just like search through every single thing. I'm going to make it easier for you to find the stuff that you're looking for. So Drupal uses its configuration, uses content type to load fields. Fields have data. You only want the fields that you need to make a node object, and then once it has all those pieces, it can go to the next step, which is the renderable array, or some people call it the renderer array. What is this thing? This is also another key concept that you want to start to understand if you're building or theming. And the render or renderable array is all the page content loaded into an array that has, okay, here's the node, and then it says, okay, I've got a title. So it'll say, title, this is my happy vacation page. Body, all the stuff that goes to the body of the node. A node that it references, the author, all the bits and pieces, those are in this renderable array. So it's turned it into something after it loaded the node into a object that you could start theming, because now you have all of those nice pieces that actually make up your content, but there's no theme, there's no visual anything attached to it. It's just raw data labeled one piece at a time so that you can find it in this structure. So an associative array is a data structure that organizes element into named key value pairs. Key being the label, value being the stuff. Key is title, value is my great vacation or whatever it is. And you can find out more about that at drupal.org node/. Now, this part of it is critical, and this is where you find the magic, because there's documentation all over the web. Some days Drupal is amazingly well documented, and some days it's the worst documented thing you ever want to do. And if you're serious about it, when you find something that's really poorly documented, people will remember that you wrote the documentation and posted it somewhere and said, you know, if you want to do this, try this. Here's some code, here's some method, here's some way of doing it. And I would say I learned probably 80% of what I know about Drupal by looking up these URLs and reading them, and then taking a nap and then reading them again, and until I actually understood what was happening. And I'm going to give you the best. I'm going to give you the best advice that I could ever give anybody who's going to go into these pages. Start from the bottom first. See if they solve the problem before you scroll for like half an hour going, oh, then they did this and then they did that. Go to the bottom. Someone will either say the issue is still open, or thanks, man. That's what did it for me. So, and then you work your way back up until you start seeing someone put in a patch. It worked. Is it in the module now? Do I have to do something else to pull the data out of it? So this, if you take away anything from this, take away that. You have something, Stan, or are you just agreeing with me in
I was just giving you a note of encouragement, man.
Okay, thank you. Cool. Okay, so this renderable array thing, it's an array, it has a name, and it will have all the pieces in it in different chunks labeled. Okay, so now we go to the next part of this. Renderable array is converted to HTML. Now you have all these things, body and title and label and all these other pieces of whatever that are coming out. You convert. How does it get converted to HTML? Well, that's what theming is all about. So we've got in Drupal 8 the Twig engine, which directs how page templates are going to act when the renderable array is passed into them. So Twig says, you know, when you get this thing, this is what you want to do. And when you have those templates, it says take this piece out of the array, the title, and put H2 tags on it, and now it is, or H1 or whatever you're putting on there, and now you have a title on your page. So that's where everything is wrapped in HTML tags inside of the theme. Twig handles it. There's ways and methods that you can adapt that code to what you need. If all of a sudden you find out it's all the way down there and you say, oh, I have this thing and I want to tag it on to the title, or do a title, what do they call that, a something that you put in front of the title, or wrap the title in with some kind of data. All of these things can be handled by Twig. Twig is remarkably flexible, and you don't want to leave all of your customizations to that point. Not a good idea. But there are things where you can get a lot of mileage out of Twig to streamline, customize, make it conform to what you want, and then that response is HTML, and it's now replaces everything else in the response with a whole. HTML is a string, so it's like one string of 200 lines, 800 lines, 1,200 lines, whatever it is. It's a big string, and the response is now converted from essentially a variable structure to a string structure. And all those strings have special names that mean special things. Okay, so now Drupal says, I got you the HTML you were looking for. Went in, got all the right fields, built them up, put them into HTML. You could send this back to the browser. Okay, Symfony, here you go. It's either, it could be small or large, but it says, I've given everything to Symfony. I'm done now. I now have to start dumping things out of my memory so I can get ready for the next page. So it doesn't want to hold all the old pages in its memory. It needs to have it nice, clean, and light so it could start building the next one. And that response, that long string of HTML, is sent back to your ISP. Your ISP, from the header and from there's I'm sure an ID, a session ID of some sort. It says, oh, yeah, the Drupal user group in DC, they just asked me for this a little while ago. I'm going to turn it back and send it over to them. And it's going to go back from that identification to the browser that asked for it. Now, everyone says, okay, we're all done. Sorry. So your browser takes in the HTML data. And in that HTML data, it says, it references CSS and JavaScript. So is anyone here that doesn't know what CSS or JavaScript is? Good. Okay, I didn't want to have to explain that. All right, so what it says is it gives you an address, a location for those specific files, pulls it down into the browser, and then it starts to use them to enhance the HTML that's there. So it takes that HTML string that's in the browser, and it builds the document object model. What's the document object model? Everything that comes in HTML is nested. So the browser says this is a child of this. This is the parent. Here's the child of that, and that's a child of the other thing. And it could go 20 layers deep, but it does build that nested collection, and that's called the document object model. Does a lot of other things, but basically, if you picture it like that, you're getting into the understanding of, oh, child of, that must be what it's wrapped in. So you start to find how you can locate individual pieces of data in the page by who their parents are. CSS is the cascading style sheet, and that makes its own model because you've got all those things in CSS that, okay, I'm referring to a child of this, and that has a child, and I want that to do something special. I want it to be green, blue background, whatever your thing is. It builds its own nested model, and at the point that your browser starts doing its job, it compares the two and says, do I have some instructions on how to paint this on the screen. Okay, so we have the nodes in the DOM, and here's some structure. So you've got the HTML, which is the big parent of everything. Then there's the head, which gives you some information about the page. There could be links to CSS in there. It could have a title that's going to appear up in the top tab of your browser. It gives you all the pieces that conform to the structure of the HTML. And then we're going to do the here's a little bit of a visual look at it, and it's also, this is the tree. There's a root, a parent, and then everything branches out of that. And if you look up, there's a lot of places on the web that you can get details about this, but if you're going to do any kind of theming or any kind of work with what's in the browser, you want to understand what the browser did when it took that giant string, hundreds of lines long, and broke it out into a tree structure. So this is critical to that process. Then you pull in your CSS files and let them build CSS trees, and these are just how they'll show up in that giant string, which is import, here's the address, it's on the server that you just got all this stuff from, and in /core/assets/vendor is a file, and it defines how things get rendered on the screen of the browser. So it pulls those down. What we do in Drupal is we do aggregation. So what we may do is take this whole list and tape them together or splice them together into one long CSS file. That's perfectly fine. Makes the browser's life a little easier. Things go a little faster. Drupal, you're always trying to save a few milliseconds here, a few milliseconds there, because at the end of that process, you may take a second, 2 seconds, 3 seconds off your page load time from raw to optimized, and then people will stay and wait for the page to load because they're not sitting there going, oh, time to get a beer, I better go check on my kid, or whatever it is that they do. You know, if your files move fast, then people pay attention longer. Okay, so this is what a cascading style sheet looks like. So you have a body, and you have two open bracket, font size, close bracket, font weight. Then you have a span, which is color red. Then if you have a P tag with a span inside of it, then it won't show it, display none. Things about floats, how you want your divs to be arranged on the page. All of these will be part of this cascading style sheet. Then when you get to that point, you have the body, and you attach font size to the body. Your P may have a font size and a weight to it, because it picks up the font size from the parent, and then it picks up the weight from specific weight from the CSS file. And then if it's a span inside of here, yes, it'll pick up the 16 points from the body. It'll pick up the 16 points from the body, the weight from the P tag, and then when it finally gets down to the span tag, it may say display none. Did all that for nothing, but it gives you the power. You have the power, and that's the part of this where you can really make a page look great, easy for people to use. It's probably better if you're not going to display it, and you know that when you're writing the code, that you get rid of the span if you can, so that and there are ways, a lot of ways to get rid of content before it gets added into the HTML string, but sometimes it's there and you just have to deal with it, so you hide it and you display none. Okay, now what the browser does is it finds out the size of the window, that's the viewport, and maybe adapts that. So it's say, are we on a mobile device or a laptop or 24-inch iMac, or everything's going to be handled differently. So it wants some numbers, and then it will take your divs. This is a nested div. Hello World is nested inside of this div, whatever it's called, I didn't put any names on it, and that's a div that's inside of this, would generally be a HTML tag that is filling up the whole size of the browser. So everything has a parent, and sometimes things like percentages refer to the size of the parent, but 50% of that. There's a lot. I mean, CSS and display can get really intricate, but this is a simplified version, so you could just see that they all get painted, they're all laid out. These things would have borders. This would be a black border, 2 points, this with a beige background, blue background with 2-point black border, and so on and so forth. So this is the basic structure of what your browser gets. Then you pull in your JavaScript files, because JavaScript files will act on that DOM. And it will say, make this one bounce, have this one come flying across the screen. This one is going to have a select element built into it. Or it's going to, when you click it, it's going to be an accordion, or all of those bits and pieces that your clients invariably will ask for. And some developer has to look into the DOM that's created by this, the structure of the page elements, and go, okay, let's go find that script that tells it to do, when you click on it, something, the drawer slides down out of the bottom, and then you see some more text. So it's hidden until you click it. On click, something falls out, you see it. If you don't click it, you never see it. These are the pieces that JavaScript handles. So the CSS is more of the how it looks, and the JavaScript is more how it behaves. Does something hide? Does something move? You know, all the other functionalities that you might add into that are browser specific. And as I said, it supports this interactivity. So, you know, there's here something, you loaded this page on. It might tell you, if it knows that you loaded the page before, it might give you a, what do you call it, a way to say, I can look up that date. So I could tell you, you loaded this page last Tuesday. And if that is in your browser, because maybe you have a cookie, it might be able to help you with that if you want to know that you viewed this page before. There's all kinds of, JavaScript can get very, very intricate, but that's what you use to, you supply the browser with these scripts so that the browser will do this for you. And then you make some money, because you go to your client and you say, okay, you put the URL in, you got the page back, the colors are right, the font size is right, I clicked on this thing and a little drawer drops down and says, you were here a week ago, and that's just what I want, they say. And then you send them a bill. Okay.
That's my favorite part.
I like when the check clears myself, but yeah.
Ted, do you have a question?
Please.
So what are the exceptions? Like when you have things like Ajax and you can click in a browser, you know, it'll do things without, I assume that's without sending a new page request.
Correct.
Where does that kind of stuff happen?
JavaScript, Ajax is a JavaScript functionality. Drupal provides it for you. It's a little complicated to use, but if you can become a master of it, you can get the JavaScript to hit the server and bring back data. And when you do that, you don't have to wait for the whole page to load. The JavaScript says, I know where that is. I live on that server. So I can go back there and say, okay, I've got some special code in me that says go into the server and hit the database and get some new stuff. Get me the part of this form that changes based on whatever information you put in there. It can reload pieces of the form for you. It can, what do you call it? It can react to content that's on the page, but Ajax is the mechanism that goes from the browser back to the server, hits the database, and brings something new out. Now, it doesn't always have to hit the database. There's different places to cache, so you don't have to actually go into the database, and you're probably better off not. But it gives you a way to go to the server and say, yeah, you know something, I want something that wasn't even loaded with this page, and it gives you a mechanism to do that. It's a little tricky, but there are some good Drupal, there's some good Drupal documentation in it, and Drupal builds it out so that it's there. I've done a lot of forms in Drupal 7 that had Ajax components built into them, and they had stubs. They have code stubs where you can go, okay, you know, I take this and I put some details in it, and boom, I'm getting what I need off of the server. So it's just a way to do it without having to go back all the way to that initial request, build that renderable array and all the other things. But you're just really thinking about getting small pieces for the most part. Otherwise, if it's a lot of stuff, you don't want to do that. You want to just rebuild the page, because you know it's going to take the same amount of time if it gets big. But if it's small, yeah, you pull something down and you've modified your page, and people go, oh, look at that. And you know, a lot of stuff that's in here, some of it is incredibly useful and powerful, and some of it you'll do because the client says, oh, I want that really cool thing where, you know, give me a carousel where things are just zipping around the page and all that. And it's like, yeah, okay, I'm a developer. You ask for it, I give it to you. That's my job. But it's not always the most powerful thing. Humans have a tendency to be amazed by these little things, and sometimes if you do them right, they're incredibly powerful. And sometimes you just entertain your clients and keep them happy, and hey, that's half the game. So, all right, anyone else questions? Please.
Thank you for your tip about looking at the bottom of the page of those Stack Overflow pages. And I'm wondering if you have any other tips about page speed. You spoke to it a little bit.
Yeah.
And I just want to see if you want to ask if you have any pearls of wisdom about using this knowledge to speed up the page.
Yes. The pearls of wisdom that I'm going to pass along are as follows. Google Chrome, being my browser of choice, has page load speed tracking built into it. And what you want to do is you want to find out the things, and you can look at it, it looks like a graph, and there's all these bars. First I loaded this, then I loaded that. It took 20 pixels, 30 pixels. Oh, this one took 250 pixels to load. There's something wrong there, and you try to find out why that happens and trim that down to the minimum possible load time, and then you will have something that okay, I solved the biggest, worst problems. One of my friends likens it to a picture of someone and they're missing their front tooth. It's like they could be a horrific looking person, but if you fix that front tooth, then everything looks so much nicer because you don't have that one big glaring error in front of you, and that can slow your page load time down. Now, if everything's running slow, you may want to go into more caching so that you're not going into the database to get things. You keep it higher up in the stack. And there's also CDNs, which will give you servers all over the world with the image in it. So instead of being in Hawaii and looking for an image on a server in London, you may go to California instead and have that image a lot closer, so it just speeds up each piece, because what you're looking at is an aggregation of different items being loaded. So CSS, you could have, I think it's Windows that supports up to 31 files. You don't want 31 files. There's advanced aggregation, a module in Drupal that'll let you batch up everything into 2 files possibly, and then you could have one that loads early and one that loads late, and that makes things move more quickly. So it's science. It's what's taking a long time, how do I cut the time down for it to load, and where do I put it so that it's cached? Yes, sir.
Related to that, I think if I follow correctly, you're referring to, say, like the network tab in the developer tools in Chrome, and you can
Yes.
see everything. Is there a module that allows to see all the requests that are being made on the database to render a specific page?
I don't know if it's a module.
Because it would seem that, like, in a related way, if you could see if that the way that you're rendering a certain page through the way you've structured the content or whatever is maybe not the most efficient, or it's like bloated, or if there's like some other way to speed up getting that same content on that page by restructuring it somehow.
Okay, that's something that would be good to go into Google, and I'm sure you'll find any number of people who will write about database queries and caching. And there are things in the database which it will start to figure out, oh, they ask for this every 5 minutes, and this they never ask for. So it will try and build you a cache of things that are constantly being requested from the database. And I'm not sure if there's a Drupal module. I wouldn't be shocked, but I haven't used it until up until this point. But that's the approach that you want to take, is start Googling. I said it before, I'll say it again. I learned 80% of what I know about Drupal through Google. And you find people, the thing that I do, that I take a note of people's names who are writing some of this stuff. And I've been in the community for a long time. Oh, this guy did that. He wrote the so-and-so module. I love that module. If he says something, I think he probably has a good handle on it. Whereas if it's somebody new and there's 15 other people, I'm going to say, okay, I've never heard of that person. I'll give his thing a glance, and maybe he's the next superstar. Maybe he's not. But I want to find the people who I can rely on more quickly and get the feedback that's coming from them, because they have a history and they're respectable in my point of view. So. But you can find out anything in any of the languages: Apache, SQL, Drupal, PHP. I'm on the PHP page, the commands page, at least once a day. And I can't remember all this stuff. I can't remember if it's needle haystack or haystack needle. But when I have to find something, I go there and I say, oh, and I put a comma and I'll put quotes on it, and boom, now I have what I need. And it came right from the PHP reference page. So, okay, any other? Great, thank you all for coming in the cold and the wet.
All right.
Thank you.
That was very informative to a wide audience, Charles. Thank you.
My
So, yeah, you're welcome. You're welcome. So I guess we'll wrap up the live video. And we have Ted Spencer, who's going to come up here and give us an update on the project he started. Before he does that, I'd like to mention Hope OneSource is having some sort of development training this weekend. They came here and spoke a few months ago, and I guess got some help. One